Today is part launch to explain what DAFNI is. It's part celebration because a huge amount of effort has gone in over the last 4.5 years to create the DAFNI system. It's part dissemination. We're going to explain again what is DAFNI, what it can do for you as a researcher, as a practitioner, what it is doing, in fact, already for the many people who are already using the DAFNI system and have been piloting it and championing it during its development. And it's also very much a day for looking ahead to the future of DAFNI. We've recently been successful in getting underpinning funding from EPSRC for another couple of years. There are a number of major projects which are already based upon DAFNI, which we'll hear from. And over those coming years, we're going to be building the research community and working very much to integrate DAFNI within the UK's digital research infrastructure. The background motivation for the DAFNI system is around the challenges facing infrastructure systems: energy, transport, digital communications, water, waste, flood risk management. And we've seen, I mean, these are systems which are absolutely essential for societies and economies all over the world. And we've seen ever increasing political emphasis on them. We have a prime minister and a government which is very much emphasizing infrastructure, as is the Biden administration in the United States. And transformation of infrastructure is absolutely central to meeting our climate commitments, not only total decarbonization of the energy system, but also electrification of transport, and removal of carbon emissions from construction materials, which is some of the most challenging issues. So infrastructure is not easy to ensure that it's affordable, that it's reliable and resilient in the face of increasing threats, that it minimizes and manages its environmental impacts, not just in relation to carbon emissions, but also in relation to impacts on biodiversity and the natural environment, and then achieving the elusive goals of levelling up. And people are looking to infrastructure in relation to the levelling up agenda in initiatives like Transport for the North. But we have a lot to learn in terms of infrastructure's role in promoting more equal development across the country. And underpinning all of this, and the COVID epidemic has underlined this as well, is the uncertainty surrounding the future of infrastructure. There are many exciting things going on too, in particular in relation to electrification of so much of infrastructure, the increasing embedding of digital technologies, sensing, operation and control, revolutions in materials. And underpinning all of that are questions and technologies for data, modeling, simulation, visualization. Modeling and simulation has become absolutely central to the way in which we plan, design, manage infrastructure assets, control them in real time. In one of the fields that I work in, water resources, one wouldn't even conceive of planning a water investment or designing a water resource system without using a simulation model. And simulation provides us with the opportunity to test systems in silico, to challenge them on the whole range of possible future conditions, future climate conditions, to optimize them, to do sensitivity analysis, to understand where they're vulnerable, how they perform, and then ultimately to link them with sensed information coming back from those systems in the form of a digital twin, so that in real time we can both simulate and learn about systems at the same time as controlling them. That's the reality and the opportunity of modeling and simulation, but there are big obstacles to that opportunity around questions of data, because there are practical questions of access, and there are genuine issues around data security, around interdependencies between infrastructure systems. On the whole, infrastructure operators and modelers, researchers know their own systems, but they're much less familiar with the systems that they depend upon. There are questions of computational resource for a lot of the ambitious things that we're aiming to do now and in the future. And there's the general question of simulation, model and code sustainability and reproducibility. We're using very complex codes, possibly developed within university departments, and the process of translating those from research into practice is a massive challenge from the point of view of reproducibility, reliability, trustability of code. And a big part of that is how we use visualization, so that people can understand what's going on in models and trust what's happening. DAFNI, the Data and Analytics Facility for National Infrastructure, aims to provide solutions to a number of those challenges that I've set out. It provides a lot of compute resource. It provides a software platform in which one can construct workflows which couple together data and sequences of simulation models, sensitivity analyses, visualizations in a completely reproducible way. And those can be handed over to other researchers who want to do system of systems modeling, or to practitioners who want to reproduce it and take the work on. DAFNI is secure, so that people who are worried about the security of their data can trust the system. And it has a searchable data and model archive. It's a place where data and models can reside, and can also link through to other parts of the national data infrastructure. And in putting the system together, we've done a whole series of pilots, and you'll hear a number of these today, which is providing use cases to make sure that the system that is being built has been fit for purpose. That includes things around digital simulations, housing, rail, the National Infrastructure Systems Model, NISMOD, some applications in the Oxford-Cambridge Arc. DAFNI is one of 3 pillars of UCRIC, the UK Collaboratorium for Research on Infrastructure and Cities. DAFNI is the data modeling and simulation pillar. UCRIC also has a series of urban observatories up and down the country, and it has some very major investments in laboratories in universities up and down the country. DAFNI was a £8 million grant from EPSRC to the University of Oxford, but to create a facility which is truly shared across the country and it is accessible to everyone. I look down the road to STFC in Harwell, who are responsible for so much of the UK's digital research infrastructure, and in particular had very successfully delivered the Jasmine system for NERC, which in many ways is a natural environment analogy to what DAFNI does for the built environment and infrastructure systems. And so the majority of the DAFNI funding has gone to STFC to invest in very large scale hardware resources in Harwell, and above all, to build the software platform and system which makes DAFNI so unique. Alongside that, there's been investment in university hardware within the UCRIT universities, which enables those universities to more efficiently use DAFNI. And in particular, there's been investments up and down the country in visualization facilities. So within Oxford, for example, we're refurbishing a building which will have a decision theatre as part of the suite of DAFNI facilities, where we can bring in both researchers and practitioners to interact with visualizations and simulations which are being run in Harwell, but people can come in and learn about that capability and use it to inform decision making. And that's happening in the UCRIT universities up and down the country. So a great deal has been achieved so far with the capital funding for DAFNI. That was a capital grant, no batteries supplied. You might question that, but we've managed to actually keep crowd-in activity around DAFNI, including a couple of very major research grants, the Open CLIM grant and the UK Centre for Greening Finance and Investment, both of which are dependent upon DAFNI and will base their modelling and simulation on DAFNI. And then, as I mentioned at the start, we've been successful in getting some further resource from EPSRC for the next 2 years to provide DAFNI free at the point of access for university researchers. And then alongside that, there's grants and projects going on which will add to DAFNI's capabilities. And then there's a costing arrangement for non-university users who need to access the facilities. And that's very much as a stepping stone towards DAFNI becoming even more integrated within the UK's digital research infrastructure. And I should really express enormous thanks to everyone who's been involved in getting DAFNI this far. Above all, the team at STFC, who you'll hear from today, who delivered the system, the DAFNI Governance Board with representatives from all of the UCRIT universities, and our expert advisory group, who's come along to our Governance Board meetings, who's really provided external scrutiny of the quality of the software engineering, of the design decisions that were made, have held the delivery team's feet to the fire, and have made sure that the system, which so much has been invested in, has really been fit for purpose. So thank you all very much for that. Today, we're going to provide an overview of the DAFNI system. We'll provide some examples of use cases, models, data analytics, which are going on DAFNI already. We'll talk about the future. And how DAFNI can and will be used in the future, and we'll have an opportunity to answer questions. Please put those in the Slido in the way that I explained at the start. And I should note that this is the first step in the launch, and that we're planning a more hands-on, interactive and practical workshop in September. And you'll certainly hear more about that so that you can get under the bonnet and really understand more about how to use DAFNI for research and for translating research into practice.